Hello students, today we are going to discuss the topic sets and relations. The credit of development of set theory goes to German mathematician Cantor. Now how will you define a set? A set is defined as well-defined collection of objects. Each object of a set is called as an element or a member of that set. A set is usually denoted by capital letter, say A, B, C, X, Y, Z, etc. And the elements are denoted by corresponding small letters. If X is an element of the set X, then we write that X belongs to X. Symbolically, this is a Greek alphabet epsilon. So how to read this? X belongs to X. The number of elements of the set A is denoted by n of A. Now a set can be represented using three different methods. The first method is called as listing method, that is roster method. Here all the elements are actually listed or tabulated. The elements are separated by comma and are enclosed in curly brackets. You should remember that the order in which elements are written is immaterial. In fact, that is why they are put not in a circular or rectangular bracket but are put in a curly bracket. For example, set A is 1, 2, 3, 4. How will you define this set? You can say that it is set of natural numbers less than 5. The second method is set builder method or rule method. Here the set is defined by some characteristic property of the elements of the set. For example, if set A is 2, 4, 6, 8 and so on, then the same can be represented as set A is set of all 2n such that n belongs to set of natural numbers. Now the third method is important, Venn diagram. Actually credit goes to two mathematicians, Venn and Euler. So we should call this as Venn-Euler diagram. Now it is mostly used to study the interrelations between sets. Here we denote the universal set by rectangle. Now what is universal set? Any non-empty set of which all the sets under consideration are subsets is called as universal set. The sets are represented by any geometrical closed curve like circle, ellipse, triangle, etc. Points inside this closed figure denote the members of that particular set. Now, what is subset? If every element of set A is also an element of set B, then set A is said to be a subset. Now, the next important concept is power set of a set. A set of all subsets of any set is termed as power set. It is denoted by P of A. Every set, here I am saying non-empty, has at least two subsets, the null set and the set itself. If n of A equal to n, that is if there are n elements in a set A, then the number of subsets of A is what? 2 raised to n. That is n of P of A equal to 2 raised to n. Consider the set A, elements are 1, 2, 3. Then what is P of A? P of A is null set, that is an empty set, which is actually denoted by Greek alphabet phi. But don't enclose phi in this curly bracket, that will mean singleton set. Okay, so this is null set, that is empty set. Then set which contains only one element, so 1, 2, 3. Then set which contains two elements, 1, 2, 2, 3, 1, 3. And finally, every set is subset of itself. So in all there are how many? 8 subsets. If you are asked to find number of non-empty subsets, then what will be that number? 2 raised to n minus 1. Yes, we have already defined universal set. Any non-empty set of which all the sets under consideration are subsets is called as universal set. It is usually denoted by U or capital X. Example, if the sets under consideration are set of even numbers, set of all natural numbers, then the universal set may be taken as set of real numbers. I'll give another example. Suppose A is set of all colleges in Pune, set B set of all colleges in India, set C set of all colleges in Asia, and if I define set X as set of all colleges in the world, then clearly set of all colleges in the world is what? It is the superset of all these sets and is called as universal set. Complement of a set, this concept is important. Let A be a subset of universal set X, then the set of all elements in X which are not in A is called as the complement of the set A, and it is denoted by AC or by A dash. Clearly, complement of complement is original set. What is A union A dash? It is X, where X is the universal set. What is A intersection A dash? It is nothing but null set. Example, if set X is 1, 2, 3, 4, 5, if set A is 2, 4, then what will be A dash? It will be 1, 3, 5. This is the diagrammatic representation of complement, right? This is the universal set X. This is set A. So the shaded region shows A dash, that is the elements which are not present in A but which are present in the universal set. Disjoint sets. Two sets A and B are said to be disjoint if they have no element in common. If sets A and B are disjoint, then what is A intersection B? It is nothing but phi. Now, operations on sets. The first is union of sets. Union of two sets A and B is the set of all elements which are either in A or in B or in both A and B. It is denoted by using this symbol. Thus, what is A union B? Set of all X such that, how to read this? All X such that X belongs to A or oblique and X belongs to B. Example, set A is ABCD, set B is CDEF. What will be A union B? Simple working rule is first write all elements in A, then consider elements in B which are not written, because in a set one element is to be written once only. C and D are already written, so I will not write them again. Two extra elements E and F are there. So what is A union B? It is set A, B, C, D, E, F. Now this is the diagrammatic representation of A union B. The shaded region represents the union of two sets A and B. Intersection of sets. Intersection of two sets A and B is the set of all elements which are present in both A and B. It is denoted by this symbol. Thus, what is A intersection B? Set of all X such that X belongs to A strictly and X belongs to B. I said strictly for this word and. X should belong to both the sets. You can compare this with HCF. Okay. Now, if A is set ABCD, B is CDEF, then what is A intersection B? Set of all common elements. Which elements are common? D and C. See, order is immaterial when you list the elements of a set. This is the diagrammatic representation. Shaded region represents A intersection B. Now this is an important concept. Set difference. The set difference of sets A and B is the set of elements which are in A but not in B. It is denoted by A minus B. So A minus B is set of all X such that X belongs to A but X does not belong to B. Similarly, what will be B minus A? Set of all X such that X belongs to B but does not belong to A. In short, elements in A, see when we say set A, there are two possibilities. Possibility number one, elements which are exclusively in A. Secondly, elements which are in B also. So in A minus B, we consider elements which are exclusively in A. So A but not B. That is what? A minus B. Example, suppose set A contains elements 1, 2, 3, 4 and B contains elements 3, 4, 5, 6. Then what is A minus B? You will notice that 1, 2 they belong to A but they do not belong to B. So 1, 2. What will be B minus A? B minus A will be 5, 6 because 5 and 6 they belong to B but they do not belong to A. Now this is important. See, A but not B. As I said, A comprises of two parts, elements which are only in A, which are common. So you exclude common elements and you have to consider elements which are exclusively in A. So this is A minus B and this is B minus A. So can I say that A minus B is A but not B? See, intersection means and can be replaced by the word but. A but not B, because B dash means elements which are not present in B. That is why I am saying what is A minus B? A but not B. So this part you have to exclude. Similarly, what will be B minus A? It is B but not A. Okay. So this is about difference of sets. Now this is important. A minus B subset of A. B minus A clearly subset of B. The sets A minus B, A intersection B and B minus A are mutually disjoint sets. What do you mean by mutually disjoint? That is, the intersection of any of these two sets is the null set. I will show you the previous diagram again. See, this is A minus B, this is B minus A and this is A intersection B. You will notice that when this occurs, this does not occur, this does not occur. When this occurs, then these two do not occur, and that is why they are called as disjoint. A minus B union B minus A equals A triangle B is called symmetric difference of sets A and B. I repeat, A minus B union B minus A equal to A triangle B is called symmetric difference of sets A and B. For example, if set A is 1, 2, 3, 4 and B 3, 4, 5, 6, then what is A minus B? 1, 2. What is B minus A? 5, 6. So what is A triangle B? It is A minus B union B minus A. That is what? It is the set 1, 2, 5, 6. These are interesting properties of symmetric difference of two sets. If A, B, C are three sets, then what is A triangle B? It is A union B minus A intersection B. What is A triangle A? Clearly it is null set or empty set. What is A triangle phi? It is nothing but A. If A triangle B is A triangle C, then clearly B equal to C. What is A triangle B? It is B triangle A. And the sixth property, A intersection B triangle C is A intersection B triangle A intersection C. Now symmetric difference, the same thing, but I have shown this using this Venn diagram. Okay, so excluding this part, this purple and red, so this is A triangle B, right? Or you can say that from A union B, just exclude this black part, which is nothing but A intersection B. So you can remember A triangle B as what? It is A union B less A intersection B. Now this concept is very important and interesting. Open interval. If A and B are real numbers such that A less than B, then the set of all real numbers x satisfying A less than x less than B is called an open interval and is denoted by enclosing A and B strictly within circular bracket. So if A and B are enclosed within a circular bracket, clearly extreme values A and B, they do not belong to this interval. So how this open interval is defined? Set of all x such that x belongs to R and A less than x less than B. Now open interval can be shown on number line as follows. You will notice that at A and B hollow circles are drawn. Why? Because A and B, they do not belong to this particular interval. Closed interval. If A and B are real numbers such that A less than B, then the set of all real numbers x which satisfy the condition A less than or equal to x less than or equal to B is called a closed interval and is denoted by enclosing A and B in a rectangular bracket. So what is the difference between open and closed interval? In closed interval, these extreme values, end values, they belong to the interval. In case of open interval, the extreme values, end values do not belong to the interval. So what is closed interval AB? Set of all x such that x belongs to R and A less than or equal to x less than or equal to B. So this is shown on number line. You will notice that here dark circles are used because A and B, they belong to the closed interval. Semi-closed or semi-open intervals. If A and B are real numbers such that A less than B, then the set of all real numbers x satisfying A less than or equal to x less than B and A less than x less than or equal to B are called semi-closed, or you can call them semi-open intervals, and are denoted using these symbols. Clearly A belongs but B does not belong. Here A does not belong but B does belong. This is how we can define them, and this is the representation of semi-closed, that is semi-open interval on number line. See, A belongs, B does not. So here hollow circle, dark circle. Here A does not but B does. So here hollow circle and here dark circle. The set of all real numbers greater than A is denoted by open interval A infinity. Now why this open interval? Because greater than A number greater than A cannot be equal to A. Again, infinity is not a real number. So please never use closed interval with infinity. Okay. So this is how we can define this interval and can be shown on number line. So hollow circle to infinity. Second, the set of all real numbers greater than or equal to A is denoted by this interval, semi-open. Here A belongs to interval, but as infinity is not a real number, there is no point in using closed interval. So this is the definition and this is the representation on number line. The set of all real numbers less than B. Less than B towards what? Minus infinity. How less we do not know, till minus infinity. So we write this as open interval minus infinity B. Again, minus infinity is something which is less than every real number. Clearly it is negative, but it is not a real number. Finally, the set of all real numbers less than or equal to B is what? This interval, semi-closed you can say, minus infinity to B. This is how it is defined. In fact, this is different. Number 6, the set of all real numbers is denoted by, this is again important, the set of all real numbers is denoted by open interval minus infinity infinity. Right? So what is open interval minus infinity infinity? Set of all x such that x is a real number minus infinity less than x less than infinity. Now these are interesting rules for inequality of real numbers. Let A, B, C belong to R. If A is less than B, then A plus C less than B plus C. That is, you can add or subtract, because subtraction is addition only. What is A minus B? It is A plus minus B. So you can add or subtract the same number from both the terms. If 0 less than A less than B and C is greater than 0, then AC less than BC and A raised to C less than B raised to C. That is, if we multiply by positive number, inequality remains the same, but if multiplied by negative, inequality reverses. I will give you one simple example. 4 greater than 1. Now multiply by 2. So what can you say about 8 and 2? Yes, 8 is still greater than 2. Now consider another example. 6 less than 10. Now multiply by minus 1. What can you say about minus 6 and minus 10? Minus 6 is greater than minus 10. Now third result is again important. Suppose A and B both are positive and A is greater than B, then 1 upon A less than 1 upon B. So if A, B are positive and A greater than B, then if you take the reciprocal, inequality reverses. Example, 4 greater than 3, but 1 upon 4 is less than 1 upon 3. Now these are important results. You can go through these results afterwards. It is regarding maximum and minimum of sets. This stands for number of elements in the set A union B and so on. One example is also taken. Now properties of union and intersection of sets. The first law is commutative law. A union B is B union A. A intersection B is B intersection A. What is associative law? A union B union C is basically A union B union C. Then A intersection B intersection C is A intersection B intersection C. Now this law is very important. In fact, these two. Distributive law, union distributes over intersection and intersection distributes over union. So what is A union B intersection C? It is A union B intersection A union C. What is A intersection B union C? It is A intersection B union A intersection C. Now these laws are very important. These are suggested by mathematician De Morgan. So these are called as Morgan's laws. A union B complement is A complement intersection B complement. So you can say that complement of union, see, complement of union is intersection of complements. Similarly, A intersection B dash is A dash union B dash. That is, complement of intersection is union of complements. Now this result is again important. N of A union B is N of A plus N of B minus N of A intersection B. You have to use common sense. What do you mean by N of A union B? Total number of elements in the set A union B. Clearly, it is total number of elements in set A plus number of elements in set B. But in this process, we are considering numbers which are common two times. Why? Once because they are in A, secondly they are in B. But in a set, one element is to be considered once only, and therefore we subtract N of A intersection from this. So what is N of A union B? It is N of A plus N of B minus N of A intersection B. This result is very important. If A and B are disjoint sets, what do you mean by disjoint? that is their intersection does not contain a single point, that is A intersection B equal to phi, null set. So what is n of A intersection B? Clearly it is 0. So addition theorem becomes n of A union B equal to n of A plus n of B. Suppose there are three sets A, B and C. Then you have to remember this formula that n of A union B union C is n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. In this case also, if sets A, B, C are mutually disjoint, then what will be n of A union B union C? Clearly n of A plus n of B plus n of C. See, here I can give you one example. Suppose set A stands for set of all boys and set B stands for set of all girls. So what will be n of A union B? Clearly number of boys, total number of boys plus total number of girls, because these two sets A and B are disjoint sets. Okay. Now this is interesting. What is n of A? See, set A consists of two parts. The elements which are in common, that is elements of A which are in B also. So n of A intersection B plus elements which are in A but not B. Do you agree with me? I repeat this. When I say n of A, by that I mean number of elements in the set A. In set A, there are two types of elements. Elements which are present in B also. So both A and B. So that number is n of A intersection B. But some elements are exclusively in A. Means in A but not in B. And so it is represented by what? N of A intersection B dash. So what is n of A finally? It is n of A intersection B plus n of A intersection B dash. Similarly, what will be n of B? It will be n of A intersection B plus n of A dash intersection B. That is, elements in B consist of two parts. Elements which are in A also. Elements which are exclusively in B. That is B but not A. Describe the following set in roster form. Set of all x such that x is an integer and minus half less than x less than 9 by 2. Minus half means what? Minus 0.5 and 9 by 2 means 4.5. So we have to list all integers between minus 0.5 and 4.5. Clearly they are 0, 1, 2, 3, 4. Okay. Why not to consider 5? Because 5 is greater than 9 by 2. Describe the following set in set builder form. So this is the set. We denote that set by C. You will observe that this can be described as set C, set of all x such that x equal to what? N upon n square plus 1. Because if you observe the numerators, they are consecutive natural number. And what about denominator? Square of natural number plus 1 always. So C is set of x such that x is n upon n square plus 1, where n is natural number which is less than or equal to 7. Check, put n equal to 1, 1 by 2 present till 7, 7 by 49 plus 1, that is 50. Yes. Next one. From amongst 2000 literate individuals of a town, 70% read Marathi newspapers, 50% read English newspaper, and 32.5% read both Marathi and English newspapers. Find the number of individuals, I'm sorry for that, find the number of individuals who read Number one, at least one of the newspapers. Second, neither Marathi nor English newspaper. And number three, only one of the newspapers. Okay. Let M denote set of individuals who read. Thank God, spelling is correct here. Who read Marathi newspaper. E, set of individuals who read English newspaper. And capital X, universal set. So n of x is what? 2000. Now 70%, percent means per 100, for every 100. When I say 70%, by that I mean 70 upon 100 time of total, that is 2000, which is 1400. What is n of e? 50% read English. So 50 by 100 into 2000, that is 1000. Now 32.5% read both. Now what is 32.5% of 2000? It comes out to be 650. Now by addition theorem, what is n of a m union e? It is n of m plus n of e minus n of m intersection e. Substitute the values, you get 1750. So number of individuals who read at least one of the two newspapers is 1750. Now secondly, number of individuals who read neither Marathi nor English newspaper means m dash intersection e dash. So what is that number? You will notice that as per Morgan's law, what is m union e dash? It is, in fact, what is m dash intersection e dash? It is m union e dash. In fact, this result is obtained from this one using De Morgan law only. Now how to get number of elements in complement? To get that number, we subtract this from n of x, right? Because the elements which are not present in the given set but are present in the universal set is that required number. So n of x minus n of m union e, that is 2000 minus 1750. So 250 is the answer. In other words, out of 2000 people, 1750 read at least one of the two. So remaining, that is 250, do not read any one of these two papers. Now number of individuals who read only one of the newspapers, that number is n of m plus n of e minus 2 times n of m intersection e, that is nothing but 1100. See, this is not difficult. Why 2 times n of m intersection e is subtracted? Because when I say n of m, there are two types of people who read Marathi newspaper. First type, those who read only Marathi. Secondly, who read both Marathi and English. We do not want that number, and that is why less n of m intersection e. Now there are two type of people who read English daily. Number one, number of persons or people who read only English daily and who read both Marathi and English. But again, we do not want people who read both. So again, n of m intersection e to be subtracted from this, and that is why n of m plus n of e less twice n of m intersection c. In fact, this can be solved easily using Venn diagram. So try to obtain the solution using Venn diagram. Now this is the set A. Then total number of non-empty subsets of A is. Now just count how many elements are there. So 3, 5, 7, 9, 11. There are 11 distinct elements in the set A. We have seen that if number of elements in a set is n, then there are 2 raised to n subsets. So here 2 raised to 11, you should know value of 2 raised to 10 at least. It is 1024. So it is 2 raised to 11, 1024 into 2, that is 2048. But that is total number of subsets. Here we are asked to find total number of non-empty subsets. So out of these many, one is an empty set. So number of non-empty subsets is 2047. So the correct option is C. If X is the universal set and AB are subsets of X such that n of X equal to 100, n of A dash is 40, n of B dash is 55 and n of A union B dash is 15, then find n of A intersection B. If you know the rules, you can easily obtain the number, or the same can be solved easily by constructing Venn diagram. That you can do later on. What is n of A? It is n of X minus n of A dash, that is 60. Similarly, what is n of B? It comes out to be 45. Now, n of A union B is n of X less n of A union B dash, that is 85. Now, what is addition formula? N of A union B is NA plus NB minus n of A intersection B. Out of these four, three values are known. In fact, we have obtained them. Substitute to get the fourth value, n of A intersection B, as what? 20. So it was given in option C. So C, Calcutta, is the correct option. Yes. What is A intersection B union A dash intersection B? You have to use common sense. See, basically the set must be B. Why? Because as I said, set B consists of two parts. Which two parts? Elements which are exclusively in B. Means what? B but not A. And secondly, elements which are in common. That is A intersection B. The same is shown here using Venn diagram. This is A intersection B. This is B but not A. Now their union. In union we consider elements which are present in first or second or both, right? But here these two are disjoint sets. So this is the final answer, which is set B given in option B. So B, Bombay, is the correct answer. Now this is again similar example. You can read this later on. Now this is an important one. Solve the following inequalities and write the solution set using interval notation. Minus 9 less than 2x plus 7 less than or equal to 19. See, here we need x, then only we can use interval. Now how to get x out of that? The first step is subtract 7. We have seen that same number can be subtracted. So if you subtract 7, you get minus 16 less than 2x less than or equal to 12. Now how to get x out of 2x? Don't say subtract x, you have to divide by 2. Now you are dividing by positive number, so inequality remains the same. So divide by 2. So minus 8 less than x less than or equal to 6. So this is semi-closed interval. So this is the answer. Okay. Minus 8 does not belong, but 6 belongs to the interval. Now this is important. Before I start explaining the solution, you should know this. X square greater than a square means, many students, they just write x greater than a. That is half truth. You have to say x greater than a or x less than minus a. Why? Because square of negative number is also positive. We will consider one simple example. X square greater than 25. One obvious answer is x greater than 5. Yes, say x is 10. 10 square 100. Is 100 greater than 25? Yes. But second is x less than minus 5. Minus 6 is less than minus 5. What is the square of minus 6? 36. Greater than 25? Yes. So you have to remember this. X square greater than a square means what? X less than minus a or x greater than a. In fact, similar inequality is x square less than a square. You can write it down. x square less than a square means minus a less than x less than a. I repeat, x square less than a square means minus a less than x less than a. That is, x belongs to open interval minus a. Okay, now we discuss this. X square minus x greater than 20. Now next step is I add 1 by 4. Why? So that this part x square minus x plus 1 by 4 becomes square of x minus half. You can check this. What is a minus b square? A square, that is x square, present, minus 2 times the product, present, plus 1 by 4, present. Now, what is 20 plus 1 by 4? 81 by 4, which is square of 9 by 2. Now, see this, x square greater than a square means x less than minus a or x greater than a. So, x minus half less than minus 9 by 2 or x minus half greater than 9 by 2. Now, don't say, sir, you have written x less than, but here it is not square of x, it is square of x minus half, and that is why I have written x minus half less than minus 9 by 2 or x minus half greater than 9 by 2. Now shift minus half to that part. So this is minus 9 by 2 plus half, that is x less than minus 4, or here 9 by 2 plus half is 10 by 2, that is 5, x greater than 5. Now how to write this using that interval notation? X less than minus 4, less than till minus infinity. So I can say open interval minus infinity to minus 4 union greater than 5 till what? Infinity. So union open interval 5 infinity. Yes, now this is again a very important topic, relations. First we define Cartesian product. See, though the word product is there, we do not actually take the product, right? See, what is Cartesian product? Let A and B be two non-empty sets. The set of all ordered pairs AB of elements such that A belongs to capital A and B belongs to capital B is called Cartesian product of set A with set B and is denoted by A cross B. So what is Cartesian product? It is basically set of ordered pairs. Okay. So what is A cross B? It is set of ordered pairs AB such that A belongs to A and B belongs to B. For example, set A elements A, B, C, B, 1, 2. Then what is A cross B? It is A1 or before that set of all elements AB such that A belongs to first set and B belongs to second set. So what is A cross B here? It is A1, A2, B1, B2, C1, C2. Don't write 1A. You can write A2 before A1, that is allowed because order is immaterial. But here order matters. What will be B cross A? It will be 1A, 2A, 1B, 2B, 1C, 2C. Clearly, A cross B is not B cross A. Of course, if two sets are equal, then A cross B will be the same as B cross A. But otherwise, A cross B is not the same as B cross A. But number of elements, yes, number of elements is the same in both. For example, here 3, here 2. So in A cross B, how many? 3 into 2, 6 elements. In B cross A, 2 into 3, which is same again, 6. So number of elements is the same, but elements are not the same. Now, this is not the new slide which I have made. This is an old slide. That is why you can see the movies like Three Idiots and New York and other. Okay. So here there are two sets, set A and set B. Now there is some rule of association because I haven't written that Amir is associated with Reddy or this Ajay is associated with Three Idiots, right? So what is the rule of association? an actor or actress is associated with the film he or she has acted. Okay, so basically if I try to obtain A cross B, it will be what? Amir, Three Idiots, Amir New York, Amir Mosam, Amir Singham, Amir Reddy, and so on. So in all, how many? 5 here and 5 here. So 25 ordered pairs will be there in A cross B. But we are not interested in all of them. We are interested in these 5 ordered pairs. Okay. And therefore, see how relation is defined. Interesting. A relation R from set A to set B is a subset of Cartesian product A cross B. I have told you that in A cross B there will be 25 elements, but in this relation only 5 elements are there. The set A is called the domain of the relation R. See, all these words are very important. Domain of the relation R. And the set B will be called as codomain of the relation R. The set of second entries of ordered pairs in a relation is called as range of the relation. So in this set, what will be the range? See, this element is not associated with any of the element. So this is part of codomain, but this is not part of range of the relation. Clearly there are 4 types of relations. This is 1 because one element is associated with one element only. In fact, I could have shown few more elements in B which are in B but which are not associated with elements of the set A. Similarly in set A also. But what is the requirement? Single element of set A is related to single element of set B. Then many one. In set language, many means more than one. So many associated with one. One many means one associated with more than one. That is many. And finally, many. Why many? Because here you will notice that one is associated with many and many elements are associated with one. Now binary relation on a set. Suppose A is a non-empty set, then every subset of the Cartesian product is called a binary relation on set A. I repeat, suppose A is a non-empty set, then every subset of the product, Cartesian product rather, A cross A is called a binary relation on set A. Now all these concepts are very important. Void relation, that is empty relation. Phi is a subset of A cross A and is called as void or empty relation. What is universal relation? A cross A is called a subset of itself and is called as universal relation. For example, a binary relation defined on set of natural numbers as the relation R is set of ordered pairs AB such that AB is 10 where A and B are members of set of natural numbers. Clearly, what is relation R? It is 1 10 because product has to be 10, 10 1, 2 5 and 5 2. Don't say 4 10 by 4 because 10 by 4 is not a natural number. Now various types of relations. Suppose A is a non-empty set and R is a relation defined on set A. Now these properties are very important. The first property is reflexive property. R is said to be reflexive if, how to read this? This is actually inverted A. You have to read this as for all, for every. Next year we'll be calling this as universal quantifier. There are two quantifiers, universal and existential. Why this is universal? Because this is for all, that is for every A belonging to set A. Ordered pair A and A, they belong to R. That is, if every element is related to itself under the relation R. For example, if R is a relation from N to N, means what? domain is set of natural number, and what is codomain? It is also a set of natural number, is given as relation R, set of ordered pairs AB such that A equal to B. Then what is relation R? 1 1, 2 2, 3 3, 4 4, etc. Clearly R is reflexive. So in general we can say a relation of the type is equal to is always a reflexive relation. What is symmetric relation? If for all AB belonging to A, AB belongs to R, implies, how to read this? Implies BA belongs to R. Here R doesn't mean set of real numbers, R means relation R. Then here we say that R is a symmetric relation. Same example, R is relation from Z to Z, set of integers. It is given by R as AB, AB equal to 10. Now AB equal to 10 gives BA equal to 10. Why? Because multiplication is commutative, and therefore we can say that the relation R is symmetric. Now transitive relation. If AB belongs to relation R, BC also belongs to R. If this implies that AC they belong to R for all ABC belonging to set A, then R is said to be transitive. For example, if R is a relation from set n to n, that is domain is natural number set and codomain is also a set of natural numbers. If relation R is defined as ordered pairs AB such that B is a factor of A. Suppose AB and BC belong to relation R, that is B is a factor of A and C is a factor of B, then A is thus in turn C is also a factor of A. I can give an example. See, if I consider 10, 20, 10. So 10 is factor of 20. Now 5 is factor of 10. So can I say that 5 is factor of 20? Yes, I can. So clearly this is transitive. This property is called as transitive property. Now a relation which is all of the above, that is a relation which is reflexive, symmetric and transitive, is called an equivalence relation. A relation is equal to defined on set of real numbers is always an equivalence relation. That is, it is reflexive, symmetric and transitive. Now this is interesting. Check if R from Z to Z, where R is ordered pairs AB such that 2 divides A minus B is equivalence relation. Listen to me carefully. Now relation R is defined as ordered pairs AB such that 2 divides A minus B, where A and B belong to Z. Okay, set of integers. Now A minus A is what? 0, and 2 divides 0. Therefore A is related with A for all small a belonging to Z, right? So R is reflexive. This is the criterion for relation to be reflexive. Let A is related with B. Therefore 2 divides A minus B. Therefore A minus B is 2m, where m is also an integer, because when I say 2 divides A minus B means what? A minus B upon 2 is any integer, say m. So cross multiplication gives A minus B equal to 2m. Now tell me what will be B minus A? It will be 2 into minus m. Note that if m is integer, minus m is also an integer. Therefore 2 divides B minus A. I'll give one simple example. Suppose B is 21 and A is 11. Then 11 minus 21 is divisible by 2 and 21 minus 11 is also divisible by 2. Okay? Therefore B is related with A. This clearly shows that the relation R is symmetric. Why? Because A is related with B implies that B is related with A. This is possible only if relation is symmetric. Now consider these two relations, that A is related with B and B is related with C. So 2 divides A minus B and 2 divides B minus C. See, this is interesting. 2 divides A minus B, right? So A minus B upon 2 is some integer. So what is A minus B? 2x. Now 2 divides B minus C also. So B minus C upon 2 is another integer, say y. So what is B minus C? 2y. Now add these two. A minus B plus B minus C is what? 2x plus 2y. Here B gets cancelled. So what remains? A minus C. RHS is 2 times x plus y. But note that x plus y is an integer. So 2 times x plus y is also an integer. And so the conclusion is 2 divides A minus C. This means A is related with B, B is related with C, implies A is related with C. And this is for all ABC belonging to set Z. So this is which property? Transitive. So R is reflexive, symmetric and transitive, and therefore R is an equivalent